All right, welcome back to Mr. PL's with Algebra 2. This is Unit 2, Topic 1, SLT3. And we're going to start off with some factoring here. So this is the warm-up. So what two numbers give you negative 16, but also add up to negative 6? So it's not 1 times 16. It's not 2 times... Oh, it is 2 times 8. So 2 times 8, and it has to be the 8 that's a negative one. So 2 times negative 8 is negative 16, and 2 plus negative 8 is negative 6. So that's x plus 2 times x minus 8. Now I can solve them by setting both of them equal to 0 and solving. And there's your answers, negative 2 and positive 8. Now the second one is the first question actually in this lesson. This lesson is about, I already went through the homework in the last video. This lesson is about solving square root equations, and we're going to determine if the solutions are extraneous or not. Two different ways. One, by putting the answers back into the two equations and see if they are extraneous because they're principal roots, so you get a negative square root. Or by graphing and seeing what happens on the graph. All right, so this first question actually takes a little bit of time. So the inverse of square root is squared. So I'm going to square both sides. Square root and squared are inverses, so that leaves me with just x. So I'm going to do the shortcut here to squaring a binomial. So times itself is 4x squared. Times itself is positive 36. So that's times itself times itself. And then multiply them by each other. That gives you negative 12x. Double it, you get negative 24x. And, okay, set it equal to 0. Subtract x from both sides. And I got 0 equals 4x squared minus 25x plus 36. Okay, and then I would use the quadratic formula to find those two solutions. There's no way I'm going to be able to factor this. Let's see, perfect square? No, because I made it not a perfect square from what it used to be a perfect square. So it looks like you had no other option than to use quadratic formula. So negative b plus or minus square root of b squared minus 4 times a times c divided by 2 times a. Alright, so opposite of negative 25 is positive 25. Plus or minus square root of 25 is 625. Minus 4 times 4 is 16 times 4 again. Should have had the calculator. Alright, so negative 4 times 4 is negative 16 times 36 is negative 576. Divided by 2 times 8 is 16. So 25 plus or minus 625 minus 576 is 49. That's a perfect number because that's a perfect square. 49 square root of 49 is both positive and negative 7. All right, then I can solve it twice. 25 plus 7. And then divide that by 16, and that gives you 2 exactly. And 25 minus 7 is 18, and divide that by 16, and you get a decimal of 1.125. Alright, so now how to solve it? So you can either take both these numbers, plug them back in, and see if it's got, going to give you a square root that's a negative. So square root of 2 is going to work out. Square root of 1.125 should also work out. So this looks like this is going to work. This is actually going to be two real solutions. Both of these numbers, when plugged back in for x, is going to give you a negative square root. So it's not going to be extraneous. Or square root of x is going to look something like this. And 2x minus 6 up to right 2, up to right 2. It's going to look something like that. So it's, and I'm not quite sure. So 2, okay, so I might have missed the way it's going to actually look. Should have gone more up in this case. All right, moving to the next question. So square on both sides. This one I think is going to be factorable. So that gives me x is x squared times itself. Multiply them by each other, get negative 6x. Double it, you get negative 12x. Subtract x from both sides, you get negative 13x plus 36. And I'm looking for two numbers that's going to add up to negative 13 that also give you 36 when multiplied. So 12 and 3 is not going to work. 9 and 4 is it. So this is x minus 9 times x minus 4. And that means I'm going to get an answer of 9 and positive 4 when you set both of these equal to 0 and solve. Now, why is that? So here's square root of x. Square root of 0 is 0. Square root of 1 is 1. Square root of 4, 1, 2, 3, 4 is 2. So this graph looks like this. I might have missed it on the last one. And x minus 6. 1, 2, 3, 4, 5, 6. There it is. And up one, right one looks like this. And it's going to hit at 9. 9, 3, around 9, 3. Yes, 9, 3 is where it's going to hit. So that is not extraneous. 4 is extraneous, because when you think of a parabola, it would look like this, but the bottom hand side doesn't exist because then it would not be a function. So x's 4 would be the other place it would hit, but this is an extraneous solution. And the reason why it's extraneous is because, like I said, it's when you put a point right here, that dotted line's that's where it would have hit, but it doesn't because we're only using the positive square roots, because there's no negative square roots. Alright, first step. I'm going to get rid of that negative 2. Divide both sides by negative 2. These cancel. Square root of x equals, divide everything on top by what's on bottom, so that gives me 3x. 8 divided by negative 2 is negative 4. Alright, so now I can do the same method before, which is square both sides. So that gives me x, that gives me 9x squared, that gives me plus 16. Multiply the two terms, you get negative 12. Double it, you get negative 24x. Alright, subtract x from both sides, and you get 9x squared minus 25x plus 16. And then I guess I'm going to have to use quadratic formula. It's not a perfect square. Is it factorable? 9 times 16? I don't even want to try to do that. So I would use the quadratic formula to find the two solutions. Now, I'm going to save a little bit of time here. And what you could do is you could plug these two into the graphing calculator. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to graph these two equations separately. So maybe I didn't go over that very well in the last. What I'm doing is I'm trying to figure out when are these two equations equal to each other. One's linear, one's a square root function. So 1, 2, 3, 4, 5, 6, 7, 8. That's the y-intercept of the linear one. Down 6, right 1. Down 6, right 1. So it's going to look something like this. And then the square root of negative 2 times the square root of x is going to look something like this. And then that answer right there, I think it's at like negative 1.7 or positive 1.7. Positive 1.7 and 1, I think, are the two solutions when you solve this. So positive 1.7 is the one that's the real one. The other one would have hit up here at positive 1. So that's the extraneous solution. The real one was then the 1.7. I think it's something like that, if my memory serves me right. All right, so these questions take a long time, so I'm going to have to skip through a lot of this and go straight to the homework. So square both sides. That gives you 2x equals x squared. Subtract 2x from both sides. Set it equal to 0. All right, this is going to be a nice, easy question because this is factorable. So divide both by x. This divided by x is x. This divided by x is negative 2. And set each one equal to 0 and solve. And there you are. You're going to get 0 and 2 as your two solutions. Let's see if one of those is extraneous. So y equals x. There's y equals x. That's the right-hand side. Square root of 2x. Square root of 2x is going to look something like this. So 2 is a solution, it looks like, and 0 is also a solution. It looks like this graph hits this graph twice in two different locations. So it looks like these are both real solutions. All right, so down here, this is squared, this is squared. So that gives me x equals x squared. Negative 2 times negative 2 is 4. Negative 2 times x is negative 2x. Double it, you get negative 4x. Subtract x from both sides. And you get negative 5x plus 4. Looks like this is factorable. It's x minus 4 times x minus 1. Negative 4 times negative 1. Negative 4 plus negative 1. And therefore your answers are both 4 and 1. Okay, x minus 2. There's x minus 2 and square root of x. Looks like that. Looks like 4 is a solution. I know I kind of missed it. And 1 is not. 1 is what would have been. That's the extraneous one. So this one's real. This one is extraneous. Not a real solution. Not if you're using the principal root. Okay. Thanks again for watching. Please give it a like to help you learn something about solving the square root functions. I know I only did 2 examples. That's what these videos are for, just for giving you a rough idea of how to do those kind of questions. Thanks again for watching. Please give it a like and subscribe if you haven't done so already. Have a great day.